Hello everyone. In this video we're going to be solving a radical equation. This is an interesting radical equation because we are going to manipulate this expression and then we're going to come up with an interesting expression. Now we're going to kind of remanipulate it and we'll make it factorable, sort of. And we'll come up with a very nice equation from there. So let's get started. We have the square root of x plus 1 minus the square root of x minus 1 over x, and that is equal to 1. And we're going to be looking for x values. With radical equations, word of caution, we have to be careful because most of the time we're going to square both sides, and that sometimes brings extraneous solutions, which means solutions that are not solutions of the original equation. Because by squaring both sides, we are actually looking at two different scenarios here. If the right-hand side equal to -1, and when you squared it, you would get the same result. That's why we sometimes get extraneous solutions. So we have to check. All right, let's go ahead and see what we can do with this. So I'm going to go ahead and square both sides. And at the same time, 1 squared is just 1, so I don't need to worry about it. I also want to talk about the domain of this function. A lot of times I'm criticized, like, why don't you talk about the domain? Yes, I should. Sometimes I don't because I don't know. Sometimes you just jump in. Anyway, so notice that we have two radicals. So x plus 1 needs to be greater than or equal to 0. Obviously, if one of them is 0, I don't think that we're going to get a solution. Like -1 is not a solution. 1 is not a solution either. So we don't have to worry about it being 0. X plus 1 needs to be greater than 0. So that means x is greater than -1. And the other radical tells us that x minus 1 over x needs to be greater than 0. And that just means that x should not be between 0 and 1. It needs to be outside that interval. Since x can't be 0 or 1, it basically needs to be either x needs to be less than 0 or x needs to be greater than 1. Let's go ahead and take a look at this on the number line and see what it means. We have the -1 here, we have the 0, we have the 1. One of the inequalities says, hey, your x needs to be greater than -1 like this. The other one says, hey, x value either needs to be less than 1 or greater than 1. So when you look at the intersection points, because you have to have both conditions met, right? You're going to get this interval, and then you're going to get this interval. So your x values are either between -1 and 0, or we can write it like this, or so we kind of write it like x is an element of this interval, or 1 to infinity. So we're going to look at the x values from that angle. And let's go ahead and see what we can do algebraically. So I already squared it, right? Let's go ahead and square it. It's a minus b squared. So let me rewrite it here. So we get to see the, oops, I wrote that too. I don't know why. It should be an x. Squared equals 1. And then a minus b squared, you know the stuff. X plus 1 minus 2 times this times that. So when you multiply them, you just get a difference of 2 squares under the radical. And then plus the second expression is squared. And that equals 1. So immediately you notice 1 cancels out. Just cancel it out. And we end up with something like this. Now, this might look a little complicated to you, and you may be inclined to isolate the radical and square both sides. So that's obviously definitely a way to do it. I haven't done it, but you could definitely do it as a second method. I was just planning to show you one single method, but you know, we could also explore this a little bit. So from here we get x squared plus x minus 1 over x, and then this expression. And now we're going to have to basically square both sides. And then when we square, we're going to get rid of the denominators because it's just going to be the x. So as long as x does not equal 0, we're good. And we can just 4 times this, right? And this is kind of nice. Well, it kind of looks like a difference of 2 squares, but x squared minus 1 is not a perfect square. Too bad. But yeah, we can definitely expand this and solve this. This is going to be a quartic. But again, we're going to have a lot of extraneous solutions, probably because we took a simple radical and turned it into quartic. So you can definitely follow this route, and I'm hoping that you're going to get some nice solutions. I haven't checked it. You can go ahead and do it for yourself. And let me know what you get. So let's go ahead and continue our path from here. So I got this. How am I going to manipulate it? I'll show you now real cool. It's going to be x minus. So let me go ahead and copy that over here. The radical expression is just that after multiplication. And then remember, we have the x minus 1 over x. So I'm going to go ahead and separate it. Let me rewrite it first. Okay. So the 1 cancels out. We can go ahead and this is the nice part. Okay, so we can separate this, right? We can kind of write it as x over x, which is 1, and then minus 1 over x. But what is so cool about this is the following. I'm going to go ahead and take this x. I want it a different color, I think. I want to take this x and pair it up with the negative 1 over x. So if you put those together, your expression is going to be more meaningful. You'll see in a little bit why. Now, if you make a common denominator, you're going to get x squared minus 1 over x. I hope it clicked by now. If it didn't, just wait a little bit. I'm going to show you what it is. Now, look at the expression inside the radical. It's x squared minus 1 over x. And what do I have here? The same thing. So we kind of have an expression and it's square. So if you call this like a, this will be a squared. And what does a squared minus 2a plus 1 reminds you? It should remind you a minus 1 quantity squared. Awesome. So this is a perfect square, and that's perfect. So we can write this as, square root of x squared minus 1 over x minus 1. So following this pattern here, where a is the radical, and then of course it is a perfect square. And it's equal to 0. It's really cool because it's equal to 0. If an equation is not equal to 0, then make sure it is equal to 0, because that's how you can solve it most of the time. So now I have something that whose squared equals 0, which means the original thing is 0. So we can kind of write it, and there's only one solution, one number whose square equals 0, right? That is 0. So set it equal to 0 and try to solve this equation. Very easy to solve. It's another radical, but again, we're doing a lot of squaring. Make sure we clean up the extraneous solution. So from here, we can just add 1 to both sides and square both sides. That's going to give us x squared minus 1 over x squared equals 1. And then obviously, you can kind of like, oops, that shouldn't be an x squared. That should be like this doesn't have any solution. Okay, there you go. So that should be an x at the bottom. And now when you cross multiply, you should be good. And you have to cross multiply it to turn it into a quadratic equation. And guess what? This becomes a really, really cool quadratic equation. Why? You tell me why. Anyways, so we get this nice equation, which has an interesting flavor. I won't tell you what it is, but I'm pretty sure you're gonna find out. And this has 2 solutions. But like I said earlier, we have to check for extraneity, or is it extraneous solutions? Whatever. I don't know if that word exists. So from here, x becomes 1 plus root 5 over 2. Did you recognize that number? It's a very special number. Yes, it is the golden ratio. Or 1 minus square root of 5 over 2. Now, here's the thing. This looks good to me and that looks good to me, but we had to check for extraneous solution. Now, who would like to plug it in here? What is the original equation? Let's go back and let me rewrite it for you. The original problem was square root of x plus 1 minus the square root of x minus 1 over x. I'm pretty sure some folks are going to find some shortcuts like, hey, you can just do this. You guys are amazing. Anyways, so if you plug in x values and then subtract them, you're going to have to deal with a lot of radicals. But don't worry, I've done it for you. So if f of x is equal to this function on the left-hand side, and if you replace x with 1 minus root 5 over 2, you get negative 1. That's what I was talking about when I said, hey, if you square negative 1, you're going to get positive 1. So unfortunately, this means 1 minus root 5 over 2 does not work. And when you check this one, it does work. And that's actually the only solution. So we end up with a really nice solution. So x equals 1 plus root 5 over 2 works. And now I'm going to show you what the graph looks like, because the graphs are awesome. So I graphed this radical function for you, the square root of x plus 1 minus the square root of that ratio, or whatever that's called, and then y equals 1. Notice that they intersect at one point because the horizontal line is tangent to the radical at a special point, which is root 5 plus 1 over 2. And you could also find out if you differentiate this function. I'm not going to get into that because I'm kind of like already running out of time, like too long. Anyways, this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.